Welcome. In this episode, I'm going to be telling you a little bit about how to use Git. Now, Git is open source distributed version control software. What this means is it's software that lets you keep track of changes that you're making to your code. And it will help you share this code with other people, and they can also make changes, and you can make sure that all of the changes that you're making remain in sync with each other. It's a very useful piece of software to know how to use, and it was originally developed as part of the development of the Linux operating systems. Now, if you go to git-scm.com, as you can see right here, you can find it there and download it and install it. It will suggest whatever is the latest version for your operating system, and once you've installed it, you can go ahead and start to use it. Now, Git is command line software, so you use it from your terminal emulator application, and in my case, I just use Macintosh's terminal. So I'm going to make this a little bit bigger so you can see what I'm doing a little more easily, and I'll move this to the center of the screen. There we go. So Git is relatively straightforward, but it can be a little bit confusing because sometimes the terminology that they choose to use is a little bit weird for their various options. So once you've installed Git, to start to use it, you first might want to configure some options. To do this, what you want to do is you want to do Git Config global, and you might want to set your username. And in my case, I'm just going to say Virth is my username. And you also might want to set your email. Git config global user.email. And I'm going to say this is my work email address at hum.nl. What this is doing is this is setting these options so when you use Git to make changes, people can see who made the changes and they'll have some way of contacting you in case a change went wrong or they just have a question about something that you're trying to do. Now, the whole point of this is to help us keep track of our code so we can go back to working versions in case we made a mistake. So in order to use it, we need to initialize the folder that contains our code. There are a couple of ways of doing this. The first thing we can do is we can initialize a folder that already exists. So let's just say I have a directory that I'm going to call Git Demo. What I can do is I can go into that Git Demo folder and I can say Git Init. What this will do is this will initialize Git for this particular folder. Once it does that, it tells me that it has initialized an empty Git repository in this particular folder. Now, I could also create a folder right from Git Init. So I can say Git Init Git Demo 2. And this will create the folder for me and then initialize the empty repository. So if we go over to my Finder, we can see I have the Git Demo, which is the empty folder, and Git Demo 2, which is also an empty folder. I'm just going to delete this second Git Demo because I don't really need it, because I'm just going to use this other folder. So let's go back into Git Demo. And now let's start to write a little bit of code. So what I'm going to do is I'm just going to open up Visual Studio Code and start to write code for this particular repository. And I'll just do something very basic like print hi there. And I'll save this as mycode.py and I'll save it in Git Demo. And then we can just go ahead and look here and we can confirm that in fact that is there. Now, to actually start tracking the files that are in this folder, I need to add it to the repository so it can then be committed. To do that, I'll say git add and then my file name. Now, I could directly just say mycode.py. Alternatively, I can say git add all. And what this will do is this will add all of the files to the repository to stage them for committing. So now what I do to actually make the commit is I say git commit m first commit. What's happening here is this will actually record the status of my repository to Git with a message. And here that message just says first commit, but often this message will say, this is what I did in this commit. And there are ways of making longer messages, but this is really, for the basics, all you'll need to know how to do. So now I have this change saved, which is great. So what happens if I want to create a new file that's going to have more code in it? I'll just call this mycode2.py, and I'll just say this is more code. I'll save this, and I'll go ahead and I'll add all, and so then I'll commit. So I'll say commit add second file. So then you can see again another file is created with one insertion. So now the state of this is saved. So this is how you keep track of the changes you made. So for example, what I can do is I can add more code to my code, and I can say this is a second, we'll say print, this is a second print statement. And I'll save it. And then if I want to add this information, I can say git add all, git commit add more code, and now we can see that I don't have any files that have been added or created. Instead, I have one file that's changed with 3 insertions and 1 deletion. So it's telling me all of the changes that Git has detected. So let's say I've made some code that does something, and I want to make sure that if I make changes in the future, it's not going to completely screw it up. So what I can start to do is I can use what are known as branches. So when you first begin working on a repository, you'll be working with what's known as the main branch or the master branch in the nomenclature of Git. To see all of the branches that currently exist, all you need to do is say git branch. And this will show you that in fact right now there is only one branch, that's only one place that's keeping track of our code. So if we want to add new features or extend our code, we can say, let's start a new branch. In order to start a new branch, all I need to do is say git branch and then create a new name. And this I might call dev for my development branch. So now if I say git branch, it'll tell me I have a dev branch and a master branch, and it'll show me that I'm in fact currently hanging out in the master branch. And you can think of these as different versions of the software that we're developing. To go to the development branch, what I want to do is I just say git checkout dev. So now, if I say git branch, we can see that I am on the development branch. So now any changes that I make will not affect that master branch. And this is a really handy thing to do. So now what I can do is I can edit my code and I can say print even more changes. I'll save this. I'll go back to Git and I'm going to go ahead and say git add all, git commit small change. So now I have this file added and then the change is now committed. So that's all fine and that works quite well. But what happens if, let's say I have added a whole bunch of code here that maybe has broken things that go on, and I decide, you know what, I want to go back to the master branch. What I can do is I can just say git checkout master. And now, if I actually look at my code here, you can see that that print statement that I had added in the development branch is gone. If I go back to the development branch, if I say git checkout dev, we can see, hey, it just came back. So if I also say something like mycode3.py, if I save this, and I'll just say hi, because I don't really care for the sake of this demonstration what's in there. Now what I can do is let's look at the Finder, and we say, okay, we have mycode, mycode2, and mycode3. So let's make sure that Git knows about all of these things. And I'll say git add all, git commit add extra file. And so now this change has been made, and we can see that it exists here. But if I go git checkout master, you can see the file goes away. So this is a way of keeping track of the state of our folder without ever losing the milestones that we want to save. So what happens then, let's go back to our development branch, checkout dev, and I'm going to clear this. What happens if I've made these changes and now I want to say, I think these changes are good, let's go ahead and merge them into that master branch. So in order to do this, I need to go to my master branch, And then what I do is I just want to go Git Merge Dev. So what this will do is this will pull the changes that I have made into this master branch. So now we can see that it has changed the two files, added a file, made some insertions and deletions. So now we can see that we have all three of our pieces of code here, and this is in fact the edited code. So now our master branch is at the same place as our development branch. We don't actually need that development branch anymore, so what I can do is I can just delete it with git branch d dev. And now I've deleted this dev branch and I have successfully used Git. Now sometimes you want Git to not remember information about a particular file. Let's say that you've deleted it. You can actually remove a file from Git tracking by saying git rm and then the name of the file. So for example, I can say ignore mycode3.py, and then it will just remove that from consideration. And you can see it actually deletes it from the folder as well. So then you can go ahead and git add, git commit, delete. And you can see that it has deleted this file. So those are the very basic things about knowing how to use Git, but how do you use GitHub? Well, GitHub is really easy to use. You can go to github.com, and once you're there, just sign up for an account. And once you've signed up for the account and logged in, then you can start to use it. So let's say I wanted to link this code repository that I'm using for this Git demo to my GitHub account. It's relatively straightforward. I just start a new repository, and I can just call this Git demo because that's what I've been calling it. I'm going to say it's public. You can make it private, but that does cost money. And I'll go ahead and I will create the repository. So once I've done this, you can actually see that I can push an existing repository from the command line. So what this lets me do is I can actually just copy and paste this. So I can say git remote add origin github.com/virth gitdemo.git and then push u origin master. So what this will do is this will link Git with GitHub and this repository in particular. So what I can do is I'm just going to go down here and I'm going to copy and paste that, and I'm going to hit enter. Now it may prompt you for your username and your password, but that's fine because it needs to actually know that to be able to log in to send the information. But now we can see, if I reload this, I have my GitHub repository, my Git repository on GitHub. Now if I want to make a change, what I can do is I can say, this doesn't really exist anymore, so we'll close that. And I'll say, just added this line. I'll save it, and I'll go ahead and I'll say git add all, git commit new comment. And now all I need to do to send that to GitHub is I just need to run git push u origin master again, and this will send whatever is in my master branch to that particular GitHub repository. Once that's done, we can see that this new comment now exists on my online repository. So essentially what this is letting me do is this is letting me share my code. Now sometimes you might want to work on somebody else's code, or let's say for example you're following the Hacking the Humanities tutorial and you want to download all of the code for that class within the command line. It's actually pretty simple. So what I can do is I can just go out to wherever I want to save this information. I'm going to create a new directory that I'll just call git demo2 because I'm not very creative. And now what I want to do is I'll go here, I'll say git demo2, and then what I can do is I can clone a GitHub repository onto my local system. In order to do that, I can check what the URL is. In this case, it is Humanities Tutorial. And what you can do is you can actually find the link to that here. So you'll see that it is the URL plus .git. and I'm going to copy that. There's a handy button where you can copy the link, and I'll just say git clone that address. And what it does is it will download everything, and now we can see that inside that folder, Git demo 2 is the humanities tutorial information. So this will let you actually download other people's codes and work with it. Now, there's another process that you might be interested in, and that's known as forking. And what will happen is if you fork a repository, it'll save it to your own GitHub account, and then you can make your own changes. And once you've done those changes, you actually have the option to suggest to whoever you forked it from to say, hey, I think I've made important, valuable changes. Will you pull that into your own repository? And that is known as a pull request. But there is one last situation I should address. So what happens if you've made changes to your GitHub repository locally while somebody else or you yourself has made changes to the same repository remotely? So let's imagine that I have a statement here called print Ubuntu. This is a Linux operating system. I'm going to save that. I'm going to go ahead and go into my terminal, git add all, git commit add Ubuntu, and I'll go ahead and say, okay, that's cool. Let's go over to the remote repository and go into my code 2, and I'm going to change it here, and I'm going to say print I like Ubuntu. And then if I commit this, what I have is a conflict between these two repositories. So when I try from down here, from my local repository to push it up, I'm going to get an error. And that error is going to tell me that, hey, there are some updates that were rejected because the remote repository contains changes that aren't local. So it says, why don't you integrate those those remote changes? To do this, I'll try git push. Excuse me, that's wrong. I should try clear git pull, and it will tell me, hey, we downloaded this. Let's go ahead and try to merge these conflicts. So I can go over to my plain text editor, and one of the cool things about VS Code is that it has GitHub integration. So I can decide, do I want to accept this change? Do I want to accept the remote change? Or do I want to keep both of them? And in this case, I might say, let's actually keep the remote change. I will save this. And then I'm going to go over here, and I'll say git add all, git commit fix conflict. And then what I want to do is I want to go ahead and say git push u origin master. And now we actually have resolution between these two files. And you'll see that the remote branch still looks like this. Print I like Ubuntu, because we actually accepted the remote changes, and now they match, so we don't have any problems at all. So that's a really quick introduction to some of the most basic features of Git and of GitHub. Now, there are many, many features that are available in both Git and GitHub, and I encourage you to explore them and play around with them, because once you have a basic mastery of Git, you can really start to contribute to a lot of open source packages. You can really help other people with their code, and they can help you with yours. So I hope you enjoyed this and it was clear. If not, please send me a message. I'm always happy to answer questions. So thank you, and I'll see you next time. Bye.